What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at our lesson 6.4, the triangle mid-segment theorem. So we're going to use mid-segments of triangles in the coordinate plane and then also use that triangle mid-segment theorem to find new distances. First thing we want to know is a mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. We're going to see a picture of that here on the next slide, but for reference, just make sure you know that that's a segment that is connecting two midpoints of two sides of a triangle. So here is a picture of that mid-segment, and it says in ABC, show that the mid-segment DE is parallel to AC and that DE is half of AC. So the first thing we want to do is find out if their slopes are the same, because slopes would mean they are parallel, so same slope. And since we have a picture of it, we're going to go ahead and just count our slope rise over run. So to get to D to E, I need to go 1, 2, 3 over 2. So DE's slope is 3 over 2. And then AC's slope is 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. So AC was 6 over 4, which does reduce to 3 over 2. So they do have the same slope. The next thing I want to do is make sure that DE is exactly half of AC. So what I would need to maybe use is the distance formula for DE and see if it's exactly half of AC. Remember, what we can do for the distance formula is using that, just plugging those numbers in to see what they have. So right now point D is at 0, -1, and point E is at 2, 2. So let's find the distance of DE. So we'll do dist of DE. Finding the distance, we have the square root of x squared minus x1 and then plus y squared minus y1. So we got 2 minus 0 squared plus 2 minus -1 squared. 2 minus 0 is 2, 2 squared is 4, and then 2 minus -1 is 3, 3 squared is 9. So we have the square root of 13. I'm going to leave it in square root mode first, and then we'll change it to a decimal. So that was DE. I'm going to erase and get some room here to do AC next. So AC, I have 1, -6, and C is at 5, 0, so just finding the distance of that. X's would be 5 minus 1 squared plus y's 0 minus -6 squared. 5 minus 1 is 4. 4 squared is 16. I'm recording that video. And then 0 minus -6 would be 0 plus 6. 6 squared is 36. So I'm going to add 16 and 36 together. And I'm going to get 52. So let's see if that's exactly half. I'm going to take my calculator and calculate the square root of 52, just a minute. So the square root of 52 is about 7.2, and that's rounded to the nearest tenth. And then the distance, so that was distance of AC is 7.2, and then DE was the square root of 13, and that's about 3.6. So yes, it is exactly half, or DE is exactly half of AC. The final thing we have here says find the coordinates of endpoints for the mid-segment EF, which is opposite of AB, and then show that EF is parallel to AB and that EF could be half of AB. So EF is not currently on our picture, but what we do want to make sure we can find is the midpoint of AC, and that's going to help us find F. So midpoint of AC, I'm just adding my x's together, dividing by 2, my y's together, dividing by 2. 5 plus 1 is 6. 6 divided by 2 is 3. And 0 plus -6 is -6 divided by 2 is -3. So 3, -3. So here's point F. So that means if I connect E to F, this is showing my mid-segment. I also want to make sure it's parallel to AB. So EF slope, I just go from E to F, so I'm going down 1, 2, 3, 4, 5 over 1. So that's negative 5 over 1. And then my AB slope, or going back from B to A, I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 2. Negative 10 over 2 is also equal to negative 5. So they are parallel. And that EF is exactly half of AB. Again, we want to find the distances of those. We can use our distance formula. Distance of AB can be found by doing changes in my x's squared minus changes in my y squared. So we've got 1 minus negative 1 squared plus negative 6 minus 4 squared. That's going to be 1 minus negative 1 is 2, 2 squared is 4. And then negative 6 minus negative 4 is negative 10. Negative 10 squared is 100. And 4 plus 100 is 104. And then for the distance of EF, again, E is at 2, 2, and F is at 3, negative 3. So we're going to find the changes in my x's squared plus changes in my y squared. So 3 minus 2 squared plus negative 3 minus 2 squared. X's, y's, cool. 3 minus 2 is 1, 1 squared is 1. Negative 3 minus negative 2 is negative 5. Negative 5 squared is 25. Put that together, we get 26. So just to double check, they are double or half of one another. The square root of 104 is 10.2 rounded, and the square root of 26 is about 5.1 rounded. So that checks out as well. So all that being said, the triangle mid-segment theorem basically says that the segment connecting the midpoints of two sides of a triangle are parallel to that third side and is half as long as the other side, and we just proved that all with that first example. Okay, so what we're going to do here is talk about a coordinate proof of how we can use that with any type of number. So we're going to use these variables here to help us. So the first thing we're going to write down is DE is mid-segment of triangle OBC. Next up, we can maybe say that D is equal to the midpoint, which would be 0 plus 2Q divided by 2. So I'm taking the midpoint from O to B, okay? And then for my Y, 0 plus 2R divided by 2, which is going to be equal to just QR, Q comma R, and E would be equal to 2Q plus 2P over 2, comma, 2R plus 0 over 2, which is going to end up being Q plus P, comma R, and this is using that midpoint formula. Okay, then I can go on and talk about maybe my slope, because I want my slope to be parallel. So slope of OC is going to be 0 because it's flat, and slope of DE then also has to be 0 since they should be parallel. So that means DE is parallel to OC. And then, let's change a color. Statement 3, to find out the distance of DE, we're just using that distance formula. The Q plus P minus Q squared, changes in x's, and then changes in y, r minus r squared would just give us P squared, which is equal to P. OC can be found by doing the changes in x's, 2P minus 0 squared plus 0 minus 0 squared, which is just going to give me 4P squared, which is equal to 2P. So DE is half of OC because P is equal to exactly half of 2P. Okay? Now we're going to talk about mid-segments. It says DE is a mid-segment of AB. Find AC. Well, if DE is a mid-segment of ABC, then that means if this is 4.8, this should also be 4.8. So all we have to do is add these together, and we can get 9.6 is equal to AC. Onward to a word problem. A walking path BD in a park intersects the sides of the park at their midpoints. You walk from the park corner A to the walking path BD, and then over the path on the other side of the park, back up to corner E, and then back down to your starting point. How many yards did you walk? Well, first we know that this is a mid-segment, so AB must also be 90. And then 216 is a full length, but also a mid-segment, so that means E to D is 108 and D to C is 108. And then to be able to find this portion, we got to do some digging here, but maybe you can think about 68 being exactly half of AE. So I'm doing 68 times 2, and that gives me 136. So I'm going to do my A to B, which was 90, plus my 68, which was B to D, plus the 108, which would be D to E, and then plus the 136 back to EA, and I'm going to end up with 402 yards walked. The last one we're going to talk about a proof, and you can write this either way you want to. I'm going to do a paragraph proof. It says in the kaleidoscope, I know that AE is equal to BE and AD is equal to CD, so show that CB is equal parallel to DE. So our given, we know AE is congruent to BE and AD is congruent to CD. So noticing where those are, AE, BE, AD, CD. And I don't know if they're all equal to the same, so that's why I just said AD is equal to CD with 2 tick marks. Okay, we can say D is midpoint of AC. So that means they are going to be all the same. So we'll do all same tick marks. And E is midpoint of AB. By definition of midpoint. So we have, since DE is connecting two midpoints, it is a mid-segment. So the CB will be parallel to DE by the triangle mid-segment theorem. And that's it. That is going to conclude our lesson today on 6.4. Hopefully this helped you a bit. If it did, give it a thumbs up and tune in next time when we start talking about indirect proofs and inequalities in a triangle. Have a great day.